Hello and welcome to another GCSE revision video. In this video I want to warn you about a common mistake that can really cost you dearly in an exam. This common mistake rears its ugly head whenever someone is asked to take the roots of both sides of an equation where there are multiple terms. The mistake is so seductive and so beautiful that it's very easy to think it must be the right answer, so beware. Okay, so what's wrong with this picture? We have a straightforward equation and we know that whatever we do to the left hand side we must do to the right hand side. So taking the square root of both sides seems like the obvious choice, right? Well, it's okay to do so, and the second line of this equation is perfectly valid. However, we run into a problem with the third line. First off, I want to thank a Cora user for this post, as it helps show just how common and easy a mistake this is to make. The problem arose when he took the cube root of both sides of the equation and found the cube root of the sum of x cubed plus y cubed by taking the cube root of the terms separately. Don't worry, we've all done it. So this is the problem. We can't just say the cube root of x cubed plus y cubed is equal to the cube root of x cubed plus the cube root of y cubed, which is the same as x plus y. Okay, so let's satisfy ourselves that x cubed plus y cubed is not the same as x plus y all cubed. Let's just shove some numbers in and see what we get. Well, let's say that x equals 1 and y equals 2. So 1 cubed plus 2 cubed is not the same as 1 plus 2 all cubed, because 1 cubed is 1 and 2 cubed is 8. But 1 plus 8 is not the same as 3 cubed, because 3 cubed is 27 and 1 plus 8 is 9. So what's going on here? The reason is that a plus b squared is not the same as a squared plus b squared. Likewise, a plus b cubed is not the same as a cubed plus b cubed. And in the same way, a plus b raised to the power n is not the same as a to the power n plus b to the power n, unless of course n equals 1. Okay, so if a plus b all squared is not the same as a squared plus b squared, what does it equal? Well, a plus b squared is equal to a plus b times a plus b. Multiplying out the brackets, we get a times all of a plus b times all of a plus b. And using the distributive property of multiplication, we can distribute this out again to say a times a plus b is equal to a squared plus ab, and b into a plus b is equal to ba plus b squared. Lastly, we can simplify this to a squared plus 2ab plus b squared. And it's this 2ab in the middle that causes all the problems. Before we go further, let's just satisfy ourselves that this is correct by shoving some numbers in. 1 plus 2 all squared is not the same as 1 squared plus 2 squared, which would be 1 plus 4 equals 5. But 1 plus 2 equals 3 and 3 squared equals 9. However, 1 plus 2 squared does equal 1 squared plus 2 squared plus 2 times 1, which is 1 plus 4 plus 4, which is 9. So a plus b all squared is not the same thing as a squared plus b squared, because, as we have just seen, a squared plus b squared is not the same thing as a squared plus 2ab plus b squared. And by the same reasoning, x plus y all cubed is not the same as x cubed plus y cubed. In fact, x plus y all cubed is equal to x cubed plus 3x squared y plus 3xy squared plus y cubed. Hopefully now it's clear that the cube root of the sum of x cubed plus y cubed is not x plus y, because if it were, then the sum of x plus y all cubed would be x cubed plus y cubed, but as we have just seen, it isn't. Okay, so where might we come into this problem in real life? Or rather, in a GCSE exam, I should say. So here's a simple trigonometry problem. We have a triangle. This length is 3 centimeters. This length is 4 centimeters. So what is this length? Well, we know Pythagoras' theorem says that the hypotenuse is equal to the square root of the 2 legs. Now it's very tempting to say that the square root of 3 squared plus 4 squared is just 3 plus 4, which is equal to 7, so the hypotenuse is 7 centimetres. That, of course, is completely wrong. So we get rid of that. So what is the right answer? I'm sorry, there are no shortcuts. We are going to have to evaluate it. So the square root of 3 squared plus 4 squared, 3 squared is 9, plus 4 squared is 16. So it's equal to the square root of 9 plus 16, which is 25, and the square root of 25 is 5. Okay, so where else might we make this silly mistake? Well, it's not really silly because an awful lot of people make it, so you shouldn't feel bad if you make this mistake, but it is nevertheless a mistake. What if you're given a question where you are asked to evaluate or to expand out the brackets x plus y squared? So how would you go about doing that? Well, the wrong way to do it is to just say, oh, well, that's easy, that's just x squared plus y squared. And we should know by now that is complete garbage. So how do we do it? Well, x plus y squared is the same as x plus y times x plus y, which is equal to x times x plus x times y plus y times x plus y times y. But x times y is the same as y times x, so this can simplify to x squared plus 2xy plus y squared. Okay, so just when you're doing your maths, I know you'll be under a lot of pressure. Just be careful whenever you get something in the form of x plus y squared. You do not be tempted to just square the individual components. And the same works in reverse. The square root of x squared plus y squared, and this is most important when you're doing your Pythagoras' theorem, is not the same as x plus y. Sorry about my handwriting. Okay, I hope you found that helpful. Good luck with your GCSEs if you are taking them this year, and I'll look forward to seeing you in another video.